So, hello guys, Joseph Sam Billigram here. You are K22CS1024 on the lab for building applications using GPT-4 experiment 6. So, in this experiment is called as AI powered medical assistant. So, the aim of this experiment is to develop an AI based medical assistant that can analyze a user's symptoms and suggest possible causes and provide basic advice and generate a health report. This project combines both knowledge based reasoning and language model intelligence using Ulama local LLMs to offer personalized and responsible health assistance. Yeah, in the real world, similar to AI assistants that are being used in telemedicine platforms, health chatbots, and patient triage systems to help users identify possible conditions before consulting a doctor. Such symptoms are not replacements for doctors but serve as an early guidance tool that can save time and potentially detect emergencies. So what it is that if for any reason you can actually search in the Google as well and AI generated responses may come, but the thing is that those responses are not valid responses or not priority based responses. Always we should go in real life to a real doctor in person to verify everything, but to save time or just to have a like a what could it be in a short time we can actually search it like this way. It's not recommended, but it is that it can be used as possible. So we're gonna go to the code. We're gonna briefly see what the code is doing. So I first set up a Olama API and I used the model right here. Okay, so uh, here we're gonna see the knowledge base. The knowledge base is like a database of what all sicknesses and what all symptoms it could be. So it contains common conditions such as cold, flu, migraine, indigestion, and chest pain. Each entry has related keywords, a short advice message, and a severity level, like how bad it is. This serves as a quick lookup layer for well-known symptoms. So here we're gonna see a knowledge-based match, where it scans the user's input for any matching keywords from the knowledge base, and if it finds a match, it returns a predefined condition, advice, and severity level. So in step 3, it is gonna see if there is no match found. The program calls Olama LLM through the function Olama response, and it sends a structured prompt instructing the AI to analyze the symptoms and suggest possible causes, home care advice, and when it is time to see a doctor. And ending with a disclaimer that this advice is not an actual advice where you should take it like as a grain of salt or as a very third or final option like that. So in step 4, we can see uh, medical assistant function. So where it combines both these applications, as it first checks the knowledge base, then falls back to the LLM for complex or unfamiliar symptoms. It also includes an emergency alert if the input mentions chest pain or shortness of breath, where the system immediately warns the user to seek medical urgent help. Like if it's like chest pain or shortness in breath, like don't stay at the same place. Immediately go to a nearest doctor or the nearest professional health assistant nearby quickly, like that. Okay, so the export report here. So this function exports all user interactions into a file named health report.txt, creating a structured record of conversations for future reference. So finally, here in step 6, it's an interactive command line loop where the user can type the symptoms and the assistant immediately provides advice. Typing report exports the conversation and exit ends the session while saving the report automatically. So we're gonna run this program in real time and see how it responds actually. Let's see for this normal thing what is gonna say like that. Let's just see that. So it just says condition is cold, severity is mild, maybe a common cold, just drink warm fluids, consider over the counter cold remedy disclaimer. So General awareness, no substitute for professional medical advice. So we're gonna put the same thing here, but we're gonna add more symptoms. So yeah, it gave indigestion. So now we're gonna go for the severe one. So you can see it immediately when the emergency alerts seek the help immediately. So now we're gonna give a come a like a prompt which is like not mentioned in the thing, and let's see how it's gonna retrieve. So now it's gonna go through the model and it's gonna see what it's gonna say. So possible causes include stress, poor sleeping habits, caffeine or screen use before bed. Establish a relaxing bedtime routine and avoid screen and coffee. So yeah, if insomnia persists, so and it says disclaimer that it's not a doctor. Okay, how about something food related? So the thing is that you have to give like a proper uh, symptoms. So it's like it's a vague symptom which I gave right now. Actually, sometimes I don't want to eat at proper times, or how about this? What do you call? So possible causes include low fiber or low protein meals, high sugar foods, dehydration, stress. So basically, this thing is not limited to the model which we provide or the sample data which we provide, but it also goes online as well, and it scans the symptoms and it gives a proper one. But at the end of the day, you have to remember this is an AI model and this is not a final sentence to be observed to be taken in a literal way. So we can finally type report and it has generated a report file right here. So we can double click that and you can see what all things we have given here. I have a mild cough, I have heartburn, I have chest pain, hard for sleeping, and I feel hungry. So the final sentence should be read disclaimer, I am not a doctor. So to summarize this experiment, this demonstrates how AI and language models can be combined with rule based systems to build a smart medical assistance. It can identify symptoms, suggest general care, detect emergencies, and create health records, all while maintaining a responsible disclaimer. So, I hope you guys enjoyed the series. Thank you all. We'll see you next time.